Hello, today I will be discussing the case in developing a loan approval classifiers. The objective was to predict whether a loan will be approved based on a variety of applicant and loan-related features. Here's the data set that is being provided. The target variable is loan status with 0 indicates rejection and 1 indicates approval. And one of the main challenge with the dataset is the class imbalance. Class 0 is rejection is much more frequent than class 1, which is approval. To address this, we experiment with SMODE, which is the technique that's oversampling, but the journey didn't end as expected. And during the exploration of the data analysis, I noticed that there's some numerical feature had the extreme outlier, and these outliers could negatively impact model performance by distorting the learning of decision boundaries. And we used the notes that was provided by the professor, and he applied Tukey's rule to detect and remove outliers. And Tukey's rule used the interquadrant range to identify values that are 1.5 times the IQR below the first quadrant and above the third quadrant. Also, we see that professor used the SMODE. Given the class imbalance, we initially use and run the SMODE, and SMODE generates semantic samples for the minority class by interpolating between existence instances. And this balances the data and helps the model learn patterns from both classes and more effectiveness. With the SMODE, the model achieved F1 score of I believe is 0.9548 with the cap boost, and the curve proved that as well, which is the highest. However, when we submit the prediction to Kaggle, our leaderboard precision was very disappointed, and despite the high F1 score locally, the model underperformed on Kaggle test data. So I think this was a sign of the overfitting. The model learned patterns from the small samples, but did not generalize well to real-world data. So we reopened another notebook without using the SMODE. So we hypothesized that removing SMODE would reduce overfitting and improve generalization on cargo test. So we apply class weighting and threshold thinning instead of the SMODE. And after removing the SMODE, we got like F1 score of 0.8296. Our leaderboard position improved significantly, and then we applied the cross validation as well as the curve. Here shows the curve. It shows that cap boost is 0.8296. SG boost is the highest, which is 0.8430. So by answering the question, we improve the model by comparing the XG boost, cap boost, and light GBM and random forest, and highlight their strength and weakness in terms of the F1 score. HG boost achieved the highest F1 score due to advanced booting techniques and business implication explain how each model implies decision-making on loan approval. and XGBoost reduce false negative and minimizing loss opportunity. And as I said before, we initially use the smooth and later remove. And secondly, we use cross validation to see how different classification are performed and plot the curve as well. What we found interesting is that the correlation metric of the predict probability shows similarly of three models, which are CAD-Boost, SG-Boost, and LightGBM. And these three are very similar on predicting the loan approval probability for each sample. And lastly, we realized that there are more models that we expected. As our leaderboard score is not the highest, we believe that some complicated models are more fitted for the dataset. And we, especially when we want to turn our model, the collab is slow, so we did not get a chance to try. So we definitely want to try to improve the classifier if we have time.